Namaste students, today I am going to teach you about basis. What is basis? If we want to define basis, we can say basis is any subset S of a vector space VF if now we will have two conditions for the basis. If we are having any subset S of a vector space, then if we are having two conditions, then it means it is a basis. First condition is S is linearly independent, and the second condition is the vectors of S generate the set V. The vectors of S generates V, or you can say that V equals to LS, or you can also say that every vector of V is expressible as linear combination of vectors of S. Okay, I am going to give you an example. Let us suppose we are having a set. Let us suppose set S is U1, U2, so on UN. Now we have to find it out that this set is basis set, and it is given that U1 is equals to 1, 0, 0, so on. It will have n elements. As the set is having n elements, we are taking vector U1 with n elements like this. Let us suppose U2 is 0, 1, 0, 0, 0, n elements, and similarly we will have all other elements of this set S, and finally we will have UN equals to 0, 0, so on 1. Now we have to show that S is a basis. Now for this one, now let us suppose we are having AI belongs to R for all I. Now what we have to show? We have to show two things. Firstly, that S is linearly independent, and secondly we have to show that S generate vector space Rn. So firstly, if AI belongs to field, then we are having linear combination like this: A1 U1 plus A2 U2 plus so on plus AN UN is equals to 0, 0, n elements 0. Now see, we are having U1 value of U1 to be this one, value of U2 is this one, and UN we are having this one. It means U1 is not equals to 0. So what it will imply? It will imply that AI is equals to 0 for all the value of I. It implies that S is linearly independent with the definition of linearly independent. So now second thing, we have to find it out whether S generate vector space or not. For this one, let us suppose we are having A1 U1 plus A2 U2 plus so on plus AN UN. This is the linear combination. So we will have A1 value of U1 we have taken 1, 0, 0, so on 0 plus A2 0, 1, 0, so on 0 plus so on plus it will come AN 0, 0, 0 till 1. Now when we will add, it will come like this: A1, A2, so on AN. So what it implies? We are having this one. It means S generates V. Vector space R raised to power n. Thus, what it means? Thus, S is basis of vector space. S is basis of vector space.